Test 1 Review Problem 12. Ankh walks 250 meters at an angle of 30 degrees north of west, then walks 600 meters due south. What direction, how far should Carlo Maria walk from where she started to go directly to her? This is a vector addition problem where we want to find the resultant vector r, which is the vector sum, in this case the vector sum of vectors a plus b, where vector a is 250 meters in magnitude at an angle of 30 degrees north of west, and vector b is 600 meters at an angle of due south. Recall that to find the resultant vector or the vector sum there are 4 steps, first of which is to find the x and y components of the resultant vector, where r sub x, the x component of the resultant vector, is the x component of the first vector being added, here vector a, plus the x component of the second vector being added, and so forth. The formula for r sub y, or the y component of the resultant vector, is the same, a sub y plus b sub y plus as many vectors as are being added. Here we only have 2 vectors that we're adding. Recall that to find the components of each vector, for instance a sub x, it is plus or minus where you manually prefix the sign depending upon quadrant. Magnitude of the vector being added, here magnitude of vector a times the cosine of the reference angle. A sub y is plus or minus magnitude of the vector times the sine of the reference angle. Let's find the x and y components of vector a, which is 250 meters at an angle of 30 degrees north of west. West means in the direction of the negative x-axis. 30 degrees north of west places vector a in the second quadrant. The magnitude of vector a is the hypotenuse, and the hypotenuse of a vector or its magnitude is always positive. We see that the x component of vector a is in the negative x direction. It's negative, whereas the y component of vector a is parallel to the positive y-axis. It's positive. The formula for a sub x, plus or minus magnitude of vector a times the cosine of the reference angle. 30 degrees is a reference angle. Remember that the reference angle is the angle between the vector and the positive or negative x-axis, whichever is closest. In this case, that would be the negative x-axis. Substituting, the SIGN is negative, as discussed. 250 meters times a cosine of 30 degrees, or a sub x is negative 217 meters, carrying 3 significant figures, since this is a 2 significant figure problem. A sub y is plus or minus magnitude of a times the sine of theta ref. That's plus. A sub y is in the positive y direction. 250 meters times the sine of 30 degrees, we get plus 125 meters. We're now ready to finish step 1, or find the magnitude of the x component of the resultant vector r sub x and the magnitude of the y component of the resultant vector r sub y. We previously found that a sub x was minus 217 meters. A sub y is plus 125 meters. We now need to find the x and y components of vector b. B is 600 meters due south. This means that b has 0 x component since it is pointed in the direction of the negative y-axis. It has no x component, so b sub x is 0. B is pointed towards the negative y-axis with a magnitude of 600 meters. This means that b sub y is negative 600 meters. We get that r sub x is a sub x plus b sub x, or minus 217 meters plus 0, or minus 217 meters. R sub y is a sub y plus b sub y, or plus 125 meters, plus a negative 600 meters, or minus 475 meters. From step 1, we have that r sub x is minus 217 meters, r sub y is minus 417 meters. We draw this out. Here's r sub x, negative x-axis direction, minus 217 meters. Perpendicular to that, r sub y, minus 417 meters. Then r, the resultant vector itself, is a vector from the first tail to the last tip. We see that r is a third quadrant vector. Step 2 is to find the magnitude of the resultant vector. We do that using the Pythagorean theorem. The magnitude of the resultant vector is the square root of the sum of the squares, as the Pythagorean theorem says. In this case, it is the square root of the magnitude of r sub x squared plus the magnitude of r sub y squared. We substitute in and evaluate, and we get that the magnitude of the resultant vector is 470 meters. From step 1, we have that r sub x is minus 217 meters, r sub y is minus 417 meters. Step 2 gave us that the magnitude of the resultant vector, the length of the resultant vector shown here, is 470 meters. Step 3, we need theta ref, or the reference angle, or the acute angle between the resultant vector and the x-axis, whichever's closest. In this case, that would be the negative x-axis. Here is the reference angle. Theta ref is tangent minus 1, or angle whose tangent is the opposite side, which is r sub y, over the adjacent side, which is r sub x. Both of those are magnitudes. We substitute in. 417 meters is the magnitude of r sub y. 217 meters is the magnitude of r sub x. And we get that theta ref is 62.5 or 63 degrees to 2 significant figures. For step 3, we found that theta ref was 63 degrees, as depicted here. Step 4, find theta in standard position. We see that the negative x-axis is an angle of 180 degrees. To get theta in standard position, we simply need to add theta ref to 180 degrees. We do that, we get 180 degrees plus 63 degrees, or 243 degrees, rounded to 2 significant figures to be 240 degrees. Now we're ready to answer the question. Ankh walks 250 meters at an angle of 30 degrees north of west, as depicted here as vector A. Then walks 600 meters due south, depicted here as vector B. What direction and how far should Carlo Maria walk from where she started to go directly to her? These vectors happen tail to tip. The resultant vector, R, or the vector sum, is the vector from the first tail to the last tip. The question is asking us to find R, and we've done that. So, Carlo needs to walk 470 meters at an angle of 240 degrees to go directly to Ankh.